All right. Hey everyone. So today we are going to talk about composition functions. So there is a little bit more algebra involved in this day than there have been in other days. So I like it a little bit more. You guys might like it a little bit less. That's to each his own kind of thing. But you guys have seen composition functions. You did a little bit of it in Algebra 1. You did like 2 days of it in Algebra 2 throughout the entire school year. So this is definitely a topic that we need to go back over because it's something that is very relevant to something that you will see in calculus. So since we're getting you guys all ready for some version of calculus next year or in your future or whenever you decide to eventually take it, this is definitely a topic that we need to discuss. All right, so here we go. Composition of functions. Okay, so before we actually get into composition functions, we're going to talk about just combining functions algebraically. So a composition is something a little bit different than this, but there are certain situations where you would want to combine more than one function to make one like larger equation. All right, and this is what we call combining functions algebraically. So if you have two functions, so we'll say we have two functions, we have function f of x and function g of x. All right, these are the things that we are allowed to do with them using algebra. So we are allowed to do the sum of two functions. All right, this just means that we're going to add these two functions. So we're adding functions. All right, and the notation for this it has two options. So depending on which textbook you have, which teacher you have, what internet website you go to, different factors that play into, when you're going to see this in your future. There are two different notations, so I'm going to show you both of them. All right, so one notation looks like this. So if we want to add f of x and g of x, you could just say f of x plus g of x. All right, another way that I've also seen this written is like this. It's more condensed, so it's going to use, oops, I forgot my parentheses. It's going to look like this, f plus g of x. All right, so the differences between the two. So f of x plus g of x, this one is telling you we're taking this function with this variable plus this function with this variable. All right, whereas the second one is saying, okay, function f and g, and then we're using the variable x. All right, so they mean the same exact thing. Both of these equations mean we're taking these two functions and we're adding them together. The reason why this one is maybe more beneficial is because it allows you to use different variables for different functions. So say you did want to combine these two, but say you wanted them to have separate variables. You could do, say we wanted it to have f to have a variable of x, but maybe we wanted function g to use the variable r. You could do plus g of r. So that's letting you, so this first option allows you to use different variables in each function if there were an instance where you would need to use different variables. Whereas this one, that second option, is assuming you're using the same variable for both functions. So it has a little bit less customization options, I guess, for that second one. Now, in this class, we're not using separate variables, but you may see sometime in, I don't know, in calculus, sometimes they use like maybe you could plug different numbers. So say we're not doing variables, say we want to plug in the value of 2 for function f, but we want to plug in the value of 7 for function g, and then we want to add them together. So that would be an instance where maybe we would want to use the two different kind of variable options because we're plugging two separate values into the equations, right? Whereas you don't have that option with the second one. You can only plug in one variable because that's what it's telling you in this setup. So anyways, that's why there are two different values. I think that this first one is more versatile, right? So this is more like, I don't know how to I was like, let me use this word. Versatile? Versatile? Whatever. Don't judge me. Anyways, it's more versatile, versatile. Whatever. It doesn't matter. We're gonna get off that topic because it's gonna make the video longer. But anyways, it can be used for more. It has more things you can do to it. You can customize it more when you use this notation, whereas this one is like less customization options, right? You only have one option for your variable. So you'll see them both ways, depending on, like I said, your teacher, depending on the class that you're taking. You may see it written two different ways. All right. But yeah, so that's kind of the benefits, I guess, to using one over the other. The f plus g of x doesn't really have that many benefits, but it does look really condensed, so it kind of looks prettier. But yeah, anyways, please don't think, a lot of times some people think that in this second one, you're not multiplying by x. It's not saying take f plus g and then multiply it by x. Please do not think that that is what that is saying there, right? Because it is not saying to multiply by x. It's saying you have function f, function g, and the variable that you are using is x. So it's like f plus g of x. Like the of means like you're doing it with the x as the variable. All right. Sometimes I see people write it where they take the two functions and then they multiply everything by an extra x, and that is not what's happening. All right. This is just function notation, right? People don't think that you're multiplying by x in this situation. You're not taking f and multiplying it by x. So why would you think it is multiplying by x in the second situation? I don't know, but people do. So I'm just saying it is not being multiplied by x there. All right. Moving onward. Okay, so the next one is difference. So you are allowed to subtract functions. All right, so difference, we know that means subtraction. So subtract functions. And since we've already talked about the notation differences, we're just going to kind of write them out for subtraction. There isn't anything new with subtraction. We're just going to put a minus sign. So you can either see this as f of x minus g of x, or you could also write it f minus g of x. Remember, we're not multiplying it by x. It's of x. Okay? Next, we have product. That means multiply. So we can multiply functions. So we have f of x times g of x. That's my little multiplication dot there. Or we can do f times g of x. And sometimes you don't see the dot, the multiplication dot. Sometimes they'll just write it like this, f of x, g of x. And we know that that means multiplication. So sometimes you don't need to put the dot there, like you just know. Same thing over here. If you just see f, g of x, we're multiplying. But mostly I see it with a multiplication symbol, like the top version. I've never really seen it without the dot. I think it's just because they want to make sure you know what's happening there. All right, last but not least, we have quotient. That means divide. So we are allowed to divide two functions. So divide functions. All right, and this is going to look like f of x over g of x, or f over g of x. Now you do have to make sure that g of x cannot equal 0. Right? Because we are not allowed to divide by 0. That's like the math rule, right? So I'm just going to move my head. It was in the way. All right. So g of x cannot equal 0 because it's on the bottom and you can't divide by 0. So you have to exclude that from any domain that you would be writing. So when g of x equals 0, you would have to exclude that from your domain. Okay. So that is combining functions algebraically. So these have different uses. Like I said, sometimes you have, I don't know, two different equations and you want to see what happens when you intersect them. You might want to use a combination of two functions. More often than not, you're probably not going to be combining functions algebraically. All right, we're going to practice it, obviously, because it's a skill that's kind of nice to know. But more often than not, if you have two functions, the general thing we're going to be doing with them is something called a composition. So we're going to do what's called compose two functions. which basically just means we're going to put one function inside of another function, which blows people's minds when we do this, but it is a very common math technique. And there are definite applications for why you would want to put one function inside of another function. So we're going to look at that. Okay, so composition of functions. All right, so like I said, here's a scenario. All right, suppose you want to calculate how much money it would cost to heat a house on a particular day of the year. All right, so there are two things happening. All right, so you have to think, all right, so the total cost, all right, depends on the daily temperature. All right, but daily temperature depends on the time of year it is. So you have two separate things. So if you ever ask your parents to look at their like electric bill, you can see that there are trends for electricity, especially if, say, your house runs on maybe gas for heat, but then uses electricity for like air conditioning, if you have air conditioning in your house, which isn't a common thing here in Seattle, which blows my mind to this day that y'all don't have air conditioning. My house does not have air conditioning. It gets so hot. I do not understand why there's no air conditioning in the state. Like, I get that you guys don't get that hot, but 80 degrees is still really hot without air conditioning. So, sorry, that was my rant for the day. It's really cool today. Like, it's a nice, like 60 some degrees, so it doesn't feel that bad. But days that get into like the 70s, I don't understand why you guys don't have air conditioning. Anyways, doesn't matter. If you look at your parents' electric bill, you'll notice that the cost depends on the time of year because of the temperature outside. So you have two different functions that are happening here, right? Like, you have the cost that depends on the daily temperature, and then the daily temperature is going to depend on the time of year it is, right? So the daily temperature in December is going to be different than the daily temperature in, say, July. All right, so since you have two different functions, what we're going to do is we want to make one giant equation that's going to take both of these functions into account. So we make one, oh my goodness, I can't believe I typed this. One function to rule them all. Oh my goodness, I must have watched Lord of the Rings that day. Or whatever that's from. I think it's, yeah, one ring to rule them all. Yeah, such a nerd. It's okay. It's cool to be a nerd. That's what I'm telling myself. All right, so anyways, we put the function CT, which is your cost daily temperature, all right, and then inside, or you put the, hang on, I'm tripping over my own ridiculousness. Okay, one more try. Okay, so you put the function that deals with the temperature depending on the time of year inside the function that is your cost depending on your daily temperature. All right, so you're combining them. So you're putting one function inside of another function. This is an example of a composition. All right, so composition, basically what we mean when we say we want to compose two functions, all right, means that, so composition functions. All right, you're putting one function inside of another function. Okay, now this confuses people every single year. All right, so we're going to look at this two different ways. We're going to look at this kind of going forward, where we're taking the two functions and we're going to put one inside of the other. And we're also going to look at it where we have two functions that are composed, and we're going to see if we can break them apart to find their separate pieces. All right, now the notation for this, okay, so just like we had notation above for algebraic, combining algebraically, we also have composition notation. The most common way of writing composition is like this. So f of, now instead of just putting a variable inside of f, we're putting g inside of f. So we would say f of g of, and then you put your variable, which generally is, we're going to use x. All right, so this says that we're taking function g and we're putting it inside function f. You can do it the other way around, right? You could also say we're taking function f and we're putting it inside of g. So you would write it like this. Now, another way that I have seen this written, I think most textbooks have started getting away from this technique because it is very confusing to look at. But I have seen it. It just, like I said, again, it depends on which teacher you have teaching you this subject. But like another way to write this is to use, let's zoom out a little bit more. There we go. Okay. Or if you want to put G inside of F, you could write F of, and it's an open circle. You can't really tell because it's not zoomed in. So it's like F open circle G. It looks like the word fog, but the open circle is not the real normal size of an O. But it's F little open circle and then G. So that's F of G. It looks like the word fog. If you're putting F into G, then you would do G of F or GOF. Like I said, these are not, I haven't seen these used by many upper level math classes. I think it's like a lower level introduction symbol. So I'm not going to use those because I think that they are very confusing. So Miss Lastly will only ever use like this terminology, but just know that this F little circle G and the G little circle F does exist. It is a symbol for that. So I don't know, maybe SATs you might see that, or I can't imagine Miss Roos uses that or Miss Logston uses that in calculus, but just know it's a thing, it exists. So if you see it in the future, you probably won't even remember that Miss Lastly told you about it, but hopefully maybe you will. I don't know. But yeah, anyways, I don't like that terminology. I will use the two highlighted ones if I'm going to do composition. Okay, so here are our two examples. So the first one is giving us the two functions. So it's giving us f of x and it's giving us g of x, and it wants us to find the composition of f and g. And it's important to pay attention to what order. So this is saying that we're taking function f and we're putting it inside of g. Okay, we're taking all of f. So we're taking all of f, which is this right here, and we're putting it inside function g. Okay, let's see what that looks like. So function f is x plus 5. So what you can do, and what some people do because it helps them make a little bit more sense of this, is they replace the f of x in the equation piece with what f of x is. So they'll do g of x plus 5 because that is f of x, right? F of x is x plus 5. All right, so now what we're going to do, just like you would if this was a number, everywhere we have an x, we're going to replace it with x plus 5 in equation g. So g is x squared. So instead of x being squared, it's the function f being squared. So we're plugging in x plus 5 for x, right? Now we just expand. Okay, so we talked about the trick for expanding binomials. Remember, it's a plus b squared equals a squared plus 2ab plus b squared. All right, so I use that every single time. So I don't recommend writing this out and then doing the whole multiplying, foiling thing. Remember this trick, we square binomials all the time. All right, so it's x squared plus 2 times 5 times x, so 10x plus 5 squared, which is 25. Okay, so that is putting one function inside of another function. Okay, you do the same thing when you put like a number inside of a function. You replace the x with whatever that number is, right? It's substitution. This is same exact technique that we're using here. It just so happens that there are variables in with the numbers this time. All right, so one function inside of another function. All right, problem number 2 is what we call decomposition. So we're decomposing our functions. Oh, I meant to go this way. Boop, and scroll, scroll, scroll. There we go. Oh, now my head's in the way. It's okay, I'll move me down here. All right, so now we're given the composition. So we're given function h of x, and we're saying that h of x is this composition of two functions f and g, and it equals x plus the square root of x plus 7. So h of x equals the square root of x plus 7. All right, and I'm saying we want to figure out what was f and what was g. Okay, now the first thing we have to do is figure out which one is the exterior function versus which one is the interior function. So if you look at it, f is on the outside, so it's the exterior function, right? It's the thing that's going to be on the outside that we're plugging something else into, whereas g is our interior function. So it's the thing that's going to be inside the other thing. All right, so that's important to kind of piece out. So f is on the outside, g of x is on the inside. Okay, so, and g. Okay, so we look at h of x and we have to ask ourselves, okay, what is the outside piece? What is like the big overall thing that's happening here? All right, so when I look at this function h of x, I see that the biggest thing that's happening, what's on the most like outer piece, is the square root, right? That's like what's on the outside, all right, visually and like actually, right? So it's the outside piece. So I'm going to say that f of x is the square root of something. My variable is x here. G of x is what is inside the function, right? So it's the interior piece. Well, if I look at this, what's inside, like I'm going the most inside, it's that x plus 7 piece. So that means that g of x is going to be x plus 7. All right, which means when I compose them, when I do f of g of x, which is what it said I was doing based on the problem up here, all right, I'm taking whatever g of x is, which in this case is x plus 7, and I'm putting it inside f, which is the square root. So I have the square root, and then what I'm putting underneath the square root is what I'm plugging in for x, which is x plus 7. So it checks out. So it looks exactly like we wanted it to. So our answer for the problem would be this. All right, so that's composition function. So that's how you put one function inside of another one, and that's also how you break a composition apart, or you decompose two functions. All right, so that is it for today. Hopefully that helps you, give you a little bit of a refresher. Like I said, you did cover this in both Algebra 1 and Algebra 2, but I know it was done, especially in Algebra 2, very briefly. So you may have forgotten it. Like I said, I think it was like 1 day or 2 days inside that first like quadratics unit. So it was barely any time spent at all on it. But like I said, here it's a quick refresher for composing and decomposing functions. I hope it was helpful. Let me know if you have any questions on your homework during asynchronous time. Bye guys.